Now we are going to discuss about electric field intensity of a circular disk. Consider a circular disk of radius capital R is uniformly charge density of rho s in coulomb per meter squared and the point P be any point on the axis of the disk at a distance from the center of this origin. Just look the figure. This is the origin. This radius is R. Okay. Now consider the angular ring of radius R and thickness dr as shown in the figure. This areas. Just look this one. This area. In the area of the circular ring is ds equal to 2 pi r into dr. Now you want to find out the electric field intensity at your point P. Now you are choosing the point P here. So this is your point P. From here to here this angle is theta. Then just imagine this outer disk, it making an angle. That angle is alpha. The height between the circular ring and the point P is h. Now the distance between this ring and the point P is d. Now you want to find out the electric field intensity at a point P due to the charged angular ring is given by dE equal to rho s into ds divided by 4 pi epsilon into r squared, but here is the distance is d, therefore we are using the notation d squared here. Clear? Now you want to find out electric field intensity, so dE equal to dEx plus dEy. So you know the basic formula for dE, so which is equal to rho s into ds divided by 4 pi epsilon into d squared. Here epsilon equal to epsilon naught into epsilon r. Just look the figure, this direction. It may be this direct like this, or it may be like this. So here the horizontal components are cancelling to each other. Therefore we have only the vertical component. So the horizontal component is called as an x component, that is equal to 0. Therefore dEx equal to 0. You have to find out only the y component. The y component is dEy equal to rho s into ds divided by 4 pi epsilon into d squared into cos theta. The concept is same as the previous case. Now you want to change only the two values. One is this differential surface ds, next one is the d squared. What is the ds? So already you know that ds equal to 2 pi r into dr. What is the d squared? You want to find out the d squared from the figure. Now come to here. So this r you want to find out from the figure also. From the figure just to find out the tan theta. So for finding the tan theta, what is the formula? Opposite by adjacent. Opposite is, this is theta, opposite is r, and this height, this is a adjacent side, so which is equal to h. Therefore tan theta equal to r by h. Now we record the r value, r equal to h into tan theta. Now you want to differentiate this side with the r, this side with the theta. So r is dr, this side is h is keep as h. For tan theta the differentiation is secant squared theta into t theta. Now from the figure find out the sin theta. So what is the formula for sin theta? Opposite by hypothesis. What is the opposite? R. Hypothesis is d. So r by d. From this one just to find out the d. D is equal to r by sin theta. Yes, now you found this d value and r value. Substitute this value to here. Now I am substituted here and also substituted here. Clear? Now I am bringing this sine squared term to the numerator. Now you have to simplify the equations. This term. So 1 by cos theta is a secant theta. So I am substituting the 1 by cos theta here and simplifying this equations. Now this cos square theta, here is a cos theta. So here is square term and this cos theta is going to get cancelled. Here is r square. So this also going to get cancelled. So and finally you are going to get rho s into 2 pi h divided by 1 by cos theta into d theta into sin square theta divided by 4 pi epsilon into r. Now you have to take this term sin square theta. You have to split this term sin theta into sin theta and simplify it. So you have to sin theta, here is also sin theta. Now this term h bring to the denominator. So now the equation become like this. Now what is the sin theta by cos theta, which is equal to tan theta? From the figure, what is r by h? You just go to the figure and find this value. R by h which is equal to tan theta. So now this term and this term is going to get cancelled. So what is the remaining? d y equal to rho s into sin theta into d theta divided by 2 epsilon. Now you want to apply then integrations. E equal to integral theta to 0 to alpha into dy. Now what is the dy value? Rho s into sin theta into d theta divided by 2 epsilon. Here this term is take it out. So rho s divided by 2 epsilon into integral theta equal to 0 to alpha into sin theta into d theta. Now what is the integration for sin theta? Minus cos theta. Limit is 0 to alpha. Just substitute the limit here. E equal to rho s divided by 2 epsilon minus cos alpha minus of minus cos 0. You know how to substitute the limit. That is upper limit minus lower limit. E equal to rho s divided by 2 epsilon. So here the cos alpha you can't do anything, keep as is. What is the cos 0 value? 1. So here is minus 1. So here is minus. So minus into minus plus. So which is equal to 1. Now E equal to rho s divided by 2 epsilon 1 minus cos alpha. From the figure just to find out the cos alpha. This is the alpha. So this is a capital R. This side is a capital R. This side is the h. What about this side? Apply the Pythagoras theorem. This is the h squared plus r squared. Okay. Now from this one just to find out the cos alpha. Cos alpha equal to adjacent side divided by hypothesis. Adjacent side is this which is equal to h. Hypothesis is this which is equal to square root of h squared plus r squared. Now you have to substitute that cos alpha value in this equation. Therefore you are going to get E equal to rho s divided by 2 epsilon 1 minus h divided by square root of h squared plus r squared. Thank you.